Hi guys, let's do one more about this chemical analysis problem. Okay, let's see this compound called compound C. This one. Yeah, by the way, this question from PU, Cambridge PU, yeah, A level. Okay, wow, you can see that, right? This compound C is extracted from this bagar, right? Excretion, wow. Maybe it come from honey badger. I don't know. Okay, let's see. There are some data table. The first one, there are several data available. This is for the first one. It is empirical formula, and then second one, bromine water test, bromine test. You see, negative, right? This result is negative. That means no CO1 present. No, yeah. And also the next one, the DNPH, right? To show the test for carbonyl group. However, also negative. That means no carbonyl group. No carbonyl group. Yeah, present. Okay, no. And then next one, acidified dichromate. Yeah, that cannot. It can oxidize, right? Can be oxidized from orange to green. So it has a kind of reducing agent, maybe aldehyde, right, or alcohol, but not aldehyde, of course, not aldehyde, because in the last one, right, it does not have a carbonyl group, so definitely it's not aldehyde. So maybe come from alcohol, right? Maybe come from alcohol. Yeah, OH group present. Yeah, OH group. Yeah. Okay. So let's see another data. MS. Of course, we should look at the last one, right? The last peak. Yeah, we call peak of molecular ion. Yeah, M plus, M plus. So the overall molecular mass, now which is 116. So let's compare its empirical formula, which is C3 H6O, right? And then times X, yeah, should be equals to the molecular mass, 116, 116. Yeah, it should be double, right? It should be double. Yeah, because the empirical formula, it should be 50x, right? I remember 50x. Yeah. So this one altogether is 58. Yeah. So x is 2, double. Therefore, it's more molecular mass. It should be yeah. The molecular formula it should be C6 double, right? H12O2. Yeah, this is molecular formula. Okay, so maybe yeah, we can use one more technique called degree of unsaturation. Yeah, to show how many double bond or a ring present. Yeah, so let's use this formula, the degree of unsaturation. So equals to the number of carbon, yeah, over 2, right? 6. Oh, only 6, sorry, only 6. Only over 2. And then 12, right? Over 2, yeah, hydrogens. Number of hydrogens over 2. And then oxygen, just ignore oxygen. And then at the end, plus 1. So altogether, H is just 1, right? So that means it might have double bond or a ring, but however, right, for our bromine test, it does not show the double bond, so it should be a ring. It might have a ring present in this molecule, and containing the OH groups. Okay, let's see the next slide to show another information. Okay, yeah, let's see two more information about this compound C. Okay, the first one infrared, right? Infrared spectrum. And second one, carbon NMR. Okay, let's look at IR spectrum first. So you can see, right, we have these major peaks. Yeah, should be come from OH bond stretching. And this one, around 1000, around just below 1100. It should be C single bond O. Yeah. Okay, but you can see, right, it has no a peak at around 1700. So definitely this compound C does not have a carbonyl group. So definitely it's not aldehyde. It should be an alcohol, that can be oxidized by the acidified dichromate. Okay, another information, the NMR, the carbon NMR. So you can see, right, we have 3 peaks for this, indicating that, right, there are 3 chemical elements of carbon. And you can see, right, there these 3 area ratio, should be equal area ratio. Okay, let's put all together this information to make this structure. Okay, let me write down the molecular formula first. Which is C6, right? H12, and then O2. Okay, let's because from the last line, I used the degree of unsaturation equation, which is 1, right? So it should be a ring. It should be a ring rather than a double bond. Okay, let me draw this ring containing 6 carbons. So we have this cyclohexane, and then because there are 2 oxygen atoms, right? It should have 2 OH groups present. So let's try this first. OH group, maybe on the adjacent side. Okay, let's see this. So when you look at a carbon NMR, carbon 13 NMR spectrum, it should have 3, right? So maybe these 2 carbons belongs to the same, and these 2 carbons, right, belongs to another type, and these 2 also. You see, right? It matches. So and all are 2 carbons, right? Okay, let's try another one. Another isomer. Maybe the OH group on the opposite side. Let's try this to see how many NMR peaks for this. So I use this. Okay. So when you use this, structure, sorry, these 2 are same, right? They are same, and these 2 are also same. So only 2 peaks for this. Only 2 NMR. Only 2. Sorry, only 2. And only 2 peaks for this structure. That means not match, right? So not match. But here, when you look, there are 3, right? There are 3 NMR peaks, and also the error ratio, right, is 2 to 2 to 2. It is consistent. With this spectrum. So I think this compound C should be this molecule, this structure. So how to name this molecule? We should call hexane, right? Hexane 1,2-diol. Hexane 1,2-diol. Okay, thank you. Bye.